I'm recording this quickly for myself because I live in a creationist household right now, and I need to make sure that their very bad understanding of evolutionary science does not rub off on me. So, it doesn't really bother me if they believe in evolution or not. I guess this will go public. But I am going to describe reality how it is. And if that offends you, that's on you. Because all I am doing is describing reality. So, radiometric dating is accurate, and it can be tested against itself, and for as long as we've had it. We can use it to find the dates of paintings and such. So, the reason why we know this, is because for as long as we've had it, things have decayed at the same rate every single time. And we've done hundreds of thousands, if not millions, of radiometric tests. I don't know the exact number, but given the number of, it's like saying how many mammograms have we done. Like, a lot. So, if the Earth was 6,000 years old, and and carbon 14, is it? I'm not 100% on that. If the carbon ion that goes into the lead ion, which exact numbers I forgot, after 5,000 years started to speed up, let's say it sped up, we would notice that some of them are moving faster, like we would notice in the samples that we've had. Let's say that instead of speeding up, there's like a world event that causes a bunch to speed up. Then we would see dramatic difference. We would see rocks that were 5,000 years old, and then right underneath them we would see rocks that are 100 million years old. The time scales are too large for it to be a non-common event. We have rocks that are 3 billion years old, and we have new rocks. And we also have rocks that are 1 million years old and 100 million years old, and each step of the way in between. We don't have this dramatic shift that we would have if radiometric dating were to randomly speed up at some point in time. So, my critic I live with, I guess I could call him, said that it's like assuming that because there's air on Earth, there's air in space. He said that assuming that radiometric dating has always been consistent and always will be. But it's not like that, because we could have never measured space when we used to think that there was ether in space. We thought that because we were unable to measure space. But we can measure the differences in time in radiometric dating, and they've always been consistent. And they always will be, predictably. Yet we can measure the differences in air density as we move up the different spheres that surround the Earth. You learn this in basic science class in high school, or at least I did, and it's one of the few things that I've learned from school that has turned out to be true. You have the 5 different spheres. You have the troposphere, which is the one closest to us, that has the most amount of air. Stratosphere, which has slightly less. I believe someone made a jump from the top of this. The mesosphere, which has less dense air still. The thermosphere, which has the second less sphere. And the exosphere, which has even less breathable air. And the combination of density in the gases are different as you go up as well. This is not my area of expertise, but my point is that air gets less dense the further away from Earth you go, or at least less dense with breathable elements. And this is easily measurable, that the atmosphere surrounding the Earth gets less dense as you go further up. but we don't see changes exponentially to the time in radiometric dating the way we see changes exponentially in the amount of air in the atmosphere as you move further out.
Because we have differences in rock samples of years, and we have differences of tens of years, and we have differences of hundreds of years, and thousands of years, and millions of years, and tens of millions, and hundreds of millions, and billions. So we would not have all of those differences if there were to be an event that sped it up. And if there are events that speed up and slow down radiometric dating that happen commonly enough for us to have those differences in measurement, then we would have witnessed one by now. Okay, on to chromosome differences. Okay, so first of all, the chromosomal examples that we have aren't always sterile. There are instances, and I'm going to start talking about human miscarriages here, so it's kind of fucked up. I mean, my family's lived through one, so, I mean, yeah, it's fucked. But people with Down syndrome, they don't always miscarry. There are instances where it's not a miscarriage. It is rare, and I don't even know if I could, in good conscience, recommend trying for one, but it happens. Meals, even sometimes, full. It's extremely rare, but it happens. The mule deletes its father's genes from the genome and essentially becomes a clone of its mother. Pretty sure. And, yeah, so meal's full. But even then, most of the time when, well, I wouldn't even say most of the time, but a hefty chunk of the amount of time when there's a difference in chromosome, it does not affect the reproduction of the next generation of that creature at all. It's just, they just don't line up, and that's fine. They still reproduce all right. Fusion and fission happen. We can see the centromeres and the telomeres of the chromosome 2 in our very DNA. So, fusion and fission has happened. We have evidence for it. Also, it's a long enough time scale, billions of years, to macroevolution not happening. We have the London Underground mosquito, which is a mosquito that was discovered in London Underground. And when they mate with surface-dwelling mosquitoes, I am going to contradict myself here, they create sterile offspring in the same way that a mule's offspring is sterile. It can still reproduce, it's just so incredibly rare, and it's so incredibly subfertile by all practical purposes. It is sterile. This is more esoteric. I'm not going to mention evolutionary science as kind of a philosophy thing. The odds that sentient life could develop are incredibly low. My response has always been, the odds do not matter at all. It's good that I'm finishing this up because I'm about to get on the highway. I'm pretty sure this is illegal and I'm recording my crimes. But, well, the odds of... I'm making myself nervous. The odds do not matter because we are sentient. If we were not sentient, we would not be able to ask, why am I not sentient? We can only ask, why are we sentient? Because we are sentient. I mean, the only reason we can ask that question is because we're sentient. So we have a 100% chance of being sentient, because it's not like rocks can question their existence. If we were a rock, then we wouldn't be able to say, why am I a rock? So, animals definitely do have some level of sentience to them, but they're not to the same level that humans are. I mean, you could go into the argument, well, then why wouldn't it be more likely for us to be, Australopithecus or a dolphin or something like that? I don't know. We are what we are. And maybe it would have been more likely, but we wouldn't be able to talk to humans about it, so there's that. Anyway, I'm out. I'm living in a creationist household. I'm studying evolution. I'm just learning. I'm learning biology as it is. I'm trying my best to not have my understanding of biology tainted, I guess you could say. And this isn't to say that, I'm trying so hard not to incorporate the creationist viewpoint. They're trying everything that they can to tear apart the evolutionary theory, and it's not working. They recently claimed that all of the bones that we have would fit in a box that could fit on this table they were pointing at, and the box that he made was smaller than a Tyrannosaurus Rex's skull. We have. I think we have a 90% complete T-Rex. It's called Black Beauty, if you're into looking at them bones. It's pretty cool. We also have quite a few Stegosauruses and a lot of humans, ancestors, Australopithecus, a bunch of other ones that I'm blanking on right now. That's the easiest one to remember because it's difficult to say. Well, it's not really difficult to say, but it's fun to say. So I got to go.